All right, I'm going to go ahead and get started. Looks like it's 10:15. Quite a turnout. This is awesome. So my name's Jeff Mielef. I'm a program manager in the actually Office 365 team now. But for the purposes of our talk today, we'll say I'm with the Exchange team because that is part of Office 365. And I'm here today to talk about Exchange 2013 sizing. So I know this is an area of great interest to a lot of our customers and partners in the field who've been very, very interested in getting Exchange 2013 into production. We haven't had a lot of sizing guidance out there until fairly recently. And so today we're going to be going through some of the information behind the guidance that we've released. I'll talk through how that guidance was developed. We'll talk about what's changed in the Exchange product and why. So, you know, in areas where resource requirements might have increased compared to previous releases, some of the reasons for that, because theoretically we don't want you having to add more processor and memory as an example for no reason. We want to actually give you something back in return. We'll talk about what those things are that you're getting back in return in the cases where we do have some resource increases. We'll talk about using the role requirements calculator. Hopefully you all are familiar with the role requirements calculator for Exchange. It's going to make what I'm describing for most of the session today a lot easier. If any of you have actually looked at the blog post that I released a few weeks ago, the sizing process for Exchange can actually be really complicated if you want to go do it by hand. It's a big pain in the butt, to be quite honest. I would never choose personally to do it by hand. Too many opportunities for error, too much math, frankly. So using the calculator is a great way to avoid that. We'll talk through some of the other tools that we have in this space, some of the other things that make the process easier, and you can also use to validate some of the outcomes of the sizing process and make sure that you're good to go before you deploy 2013 into production. I have Q&A on the slide. Realistically, we're probably not going to have a huge amount of time for Q&A. I may have time for one or two questions at the end. I will be more than happy to stand outside the room after the session for a bit. I will also be at Ask the Experts this evening and highly encourage you, if you have sizing questions, to come see me as well as Ross Smith, who is the man behind the calculator at Ask the Experts, and ask us any questions you have in that forum. Sizing questions, kind of hard to answer in many cases in this type of forum. So let's go ahead and jump in and talk about the sizing process. And we'll start with just a little bit of background, a little bit of context to get us all on the same page. So I've been with Microsoft about 13 years, and I've worked on performance and scalability that entire time in the Exchange group. And the process of developing sizing guidance for Exchange was certainly ongoing when I arrived at Microsoft in 2000. We've been in this business of creating strong sizing guidance, strong best practices for our customers and partners for a very long time, and we're pretty darn good at it. I love getting emails and phone calls from other product groups at Microsoft and being told, hey, we just met with a customer who told us that Exchange has great sizing guidance and wants to know why we don't have something equivalent. Go fix that. That's great feedback for us to hear. We love knowing that what we're producing is actually used. Historically, our sizing guidance has come from two places: test labs and production. You know, in terms of test labs, when I started in 2000, one of the first things I was working on was a 1 million user deployment to understand the impact of deploying Exchange 2000 in a hosting environment for a large number of OA users. It was a huge test, 1 million users running simultaneously with ESP. Anybody remember the Exchange stress and performance tool? A few people, yeah. We don't run those types of tests so much anymore because they're really expensive. Months and months of test work to get those done. So over time, we're shifting a little bit more towards gathering that data out of production deployments rather than test labs. We find that data is much more reliable and, frankly, a lot cheaper for us to get access to. Makes us a little more agile in releasing sizing guidance as well. So in terms of the different types of data that we get, when you think about Exchange sizing guidance, I/O is really important to Exchange, right? That IOPS guidance that we produce really defines what your storage architecture is going to look like. And the IOPS guidance that we produce, like everything else, historically has come from test labs and production. The data that we produce that goes into the calculator and goes into the sizing guidance on the blog and on TechNet, that comes from production. Oftentimes, you'll see us quoting IOPS reduction numbers around the time a product releases. In many cases, those numbers are coming from test labs, and then we'll go refine them with production observations and tell you what you should really size for. It's often a little bit of a difference in between those numbers from test labs and what we actually end up with in our sizing guidance based on production. And I'll talk through the specific example of that for 2013 in a few minutes. So typically what we do is go and isolate buckets of users. So those of you who've sized Exchange before probably know that we define user profiles based on number of messages sent and received on average per user per day. So a profile might be something like 200. That means that if I have the 200 profile, if I add up the number of messages that are sent to me and the number of messages that I send, on average, that's going to be about 200. In reality, my user profile is a little higher than that. But this is all about averages, right? So not specifics for an individual user. So what we do is we take Microsoft employees and we put them into buckets and move them around so they're on specific databases. And then we monitor performance over some time period. Could be a week, could be a month. Depends on what we're trying to do. And we see what the I/O numbers look like on those databases. That lets us plot a nice line, ideally. If it isn't linear, then we go and figure out why not. We want it to be as linear as possible. And that gives us a formula that we can then use to develop sizing guidance. That's where that IOPS guidance comes from. We are very good at measuring I/O. We've been doing that a long time. The fact that we've been focused for the last 2 or 3 releases on reducing IOPS as much as technically possible within the time frame that we have to get a product out to you means that we spend a lot of time looking at this data. So we're very comfortable with our IOPS guidance. So I mentioned that we're looking more and more at production data. Exchange 2013 actually has a really cool feature in it called the Exchange Diagnostic Service. Some of you may have noticed this running if you have 2013 in production or if you're using it in a test lab. EDS actually has a couple of purposes. Probably the most obvious is performance data collection. So if you go look in the logging directory under the Exchange 2013 install path, you'll see a diagnostics directory. And under there will be some additional subdirectories. One of them is called daily performance logs. And that will contain 5 days worth of performance data for that particular server. This is there out of the box. You don't have to do anything. Just by installing Exchange, we actually create a performance collector that's gathering this data for you. And that's there for a number of purposes. You can certainly use it for any reason you want. We have it there for ourselves for a couple of purposes. One of them is if you call into Microsoft support with a performance issue, I love the fact that support isn't going to say to you, well, we need you to reproduce the problem with performance logging. We have performance logging. We shouldn't have to have you reproduce that problem. I'm not going to guarantee that we'll never have to ask people to reproduce perf problems again, but this should dramatically cut down on that because we have 5 days of performance history for that server with the collection of counters that we use most often to diagnose performance issues. That's fantastic. The other thing that we use this data for is actually internal for our own production deployments. We collect this data into a giant data warehouse. Not for your deployments, for our deployments. We're not going and gathering perf data off of your servers. But for Exchange Online, our very large hosted deployment, for our MSIT deployment, and for our dog food deployment that hosts the Exchange product group, we have going on a year or maybe more performance data for thousands of Exchange servers that those of us in the business of creating sizing guidance or looking for performance bugs can go access very quickly. It's hosted in Azure. Great example of using some Microsoft technologies to solve problems. We have an Azure web service, an Azure website that provides visualization ability to this data, and the data itself is stored in SQL Azure. So that's actually where a lot of the data that informed the sizing guidance for 2013 came from. We can go build very complex queries to go pull things out and model how Exchange performs in production. So be aware that this data is there. Highly encourage you to use it for capacity planning. You could have a script that regularly kicks off on your Exchange servers and uploads this data into SQL using the Logman tool that comes with Windows. Lots of different ways you could use this for trending. So be aware that it's there. So in our sizing guidance, it's also important to remember that we don't cover everything. Given that we're, for the most part, basing our sizing guidance on Microsoft production deployments, that means that for the most part, we're using the Microsoft collection of clients. I'm off the top of my head, I don't know how many BlackBerries, as an example, run against Exchange dog food, but I'm willing to bet it's a fairly low number. In general, third-party solutions don't get a lot of coverage within our sizing guidance, and we rely on our partners to provide guidance on how those third-party products impact Exchange sizing, simply because we don't have great visibility into that. So be aware of that. Once you go through the Exchange sizing process using the role requirements calculator, you may have to add on some additional cost due to third-party solutions. Line of business applications, obviously, we have no visibility into. I have no idea what applications you may have implemented in your own companies that interact with Exchange. And the impact of those can be very minimal, or it can be really almost painful, just simply depending on what type of data is being accessed in Exchange and how that data is being accessed, and how tuned the application is from a performance perspective. So that's an area where typically an IT shop is going to have to do some of their own performance analysis and sizing to figure out what that impact is going to look like. Usually involves some lab tests. So be aware of that. The product also is changing constantly. We've moved to this cumulative update plan within Exchange 2013. We're going to be regularly providing new code to you, and we're going to be regularly deploying new code in our data centers. And that new code has performance, scalability, sizing changes associated with it. So the performance sizing guidance that we released recently is, for the most part, specific to CU1. And as we continue to release cumulative updates, you can expect that we will, on occasion, release updates to sizing guidance as well as the calculator to reflect those changes in the product. This is actually a slide that I presented at an internal technical conference for our field a few months prior to the release of our official sizing guidance. I left it in here because I think it's valuable to point this out, just for you to be aware of. If you're in a situation in the future where you need to deploy a version of Exchange and you don't have sizing guidance, or you're in one of the cases I mentioned previously with a third-party product, a line of business application, et cetera. You don't actually have very specific details on how to plan for the amount of hardware you'll need. This is kind of the fairly obvious way to deal with that problem, right? I admit, this should be fairly obvious, but it's worth mentioning. Lab testing is always an option here, right? You can use tools to generate client load, and we'll talk about some of those tools in a few minutes. You can certainly over-deploy hardware. I'm sure if there's any of our hardware partners in the audience today, they're going to love me saying that. But in general, Exchange runs great when it has extra resources available for it. So over-deploying hardware, certainly an option. And you can then learn from that deployment over time, see how much you've over-deployed, and as your user base grows, you can kind of scale back that extra amount of hardware that you have in the environment. Consider a pilot. This is certainly something that we encourage some of our early adopters to do. Don't take all of your users and put them on the latest and greatest. Pick a small percentage of them. Figure out a scaled down unit of brick, unit of scale hardware set for that pilot, and see what the impact is of deploying that pilot user group on that hardware. That'll give you quite a bit of information about how the system will look at full scale, right? High availability requirements oftentimes will dictate your hardware requirements, not necessarily the specific performance requirements of a given number of users. Oftentimes, you actually have to increase the amount of hardware you're deploying to provide the high availability requirements that you have in your environment. So, if you don't have data on what the specific performance impacts are of some number of users at some profile, maybe start with the high availability requirements and see if that leads you in the right direction towards defining what that hardware looks like. And then over time, add more hardware as needed based on monitoring. If you don't have guidance, keeping a very close eye on what you have deployed is really critical. You have to watch trends. You have to be prepared to add more hardware on demand to be able to meet that requirement. So start to finish, just a couple of quick overview slides to kind of define what the sizing process for Exchange looks like. This is nothing new to 2013. This is the process that we've been advocating for years, but it's worth reviewing. So understanding what the current guidance is, obviously step number one. As I mentioned, this may be changing on an ongoing basis as the product changes underneath us. So TechNet is typically the place you go for this. The Exchange team blog may also be a place where guidance is released prior to it going to TechNet. Understand what the best practices are currently. Collect data on your existing deployment. So that's user profiles, understanding how many messages a day users are sending and receiving. This used to be fairly straightforward in prior releases with a tool called the Exchange Profile Analyzer, EPA, that would go and look at the data in all your users' mailboxes and actually give you very detailed information on what these profiles were. EPA used DAV to access mailbox data, and we actually haven't supported DAV as an access method against Exchange since Exchange 2007. So EPA is not an option with 2010 and 2013, but you can get this data from message tracking logs, and you can also estimate this data based on performance counters. And there's some information on the message tracking log method of collecting this data in the sizing guidance blog post that I'll give you a link to towards the end. You also need to know average message size. That helps to inform a number of the calculations that we use for sizing Exchange. So understanding what that looks like for your specific environment, very important. We see a huge range of average message size in the field. I've seen average message sizes anywhere from 30K all the way up to, I think the highest I've seen is in the upper 800Ks, close to a meg. You may have larger, it's entirely possible, but that difference makes a huge difference in terms of things like the amount of data in ESE transaction logs, the amount of data in the transport queue. There's many, many places in the sizing process where that plugs in as a number into the calculation. So very important to understand that. And that can be collected via performance counters. Then you need to think about specific requirements for your business. And these are things that only you know. I have no idea what these numbers are going to look like for your particular case. The number of database copies that you need for high availability. We certainly have best practices guidance for different scenarios in this space. But I've met with many, many customers over the last, well, since as long as we've had DAGs, to talk through a number of copy requirements. And pretty much every conversation I've had in this area has resulted in my eyes opening a little bit wider. There's a lot of different needs around this, and a lot of specific reasons for doing things in terms of number of copies that I would never have dreamed of. Backup requirements also play a major part in the sizing process. I'd certainly love it if you considered using Exchange native data protection and not, basically using the functionality built into the Exchange product to simplify what you're doing and retain data that way. I realize that's not an option for many people in certain industries with certain compliance requirements, et cetera. So knowing what those backup requirements are is going to dramatically impact sizing requirements. The storage architecture you define. Are you going to use a SAN? Are you going to use JBOD, direct attached? Are you going to use something in between? These things will also impact the storage, the storage sizing process, but the sizing process more broadly. I'm not going to go through every single one of these things, but where you have specific business requirements around your messaging system, you need to kind of document those things up front and use that information going into this process. So once you have all this information, ideally you have the role requirements calculator, and you basically encode as much of those requirements as possible into the calculator and get your options. The calculator is actually going to provide, in some cases, multiple options, particularly around storage. Different drive types can be modeled. Different connectivity types can be modeled, whether it's SAN, direct attached, et cetera. And once you're at this phase in the process, you can think through what your options are and what the best choice for your business is. Cost is sometimes a factor here, not always. Different RAID options will have different rebuild times. So thinking through what happens when a failure occurs, that's important to model, important to think through in the process. It might be cheaper to deploy in a certain way, but you might end up in a situation where you have arrays in a degraded mode with reduced I/O or increased risk of failure for a week while that array rebuilds, right? That may not be acceptable to you. Once you've gone through that process, made your final decisions, your design's final, document it. This is actually extremely useful so that you can go back in the future as your system grows and figure out from a capacity planning perspective, were those predictions accurate? And if not, how can we tune things to make them a little more accurate? Maybe Microsoft's sizing guidance was a little bit off. We'd love to hear that feedback. Maybe there were some inputs into the calculations that were a little bit off as well. That's entirely possible. Given that things like average message size aren't, super easy to measure. Things like user profiles also aren't super easy to measure, and you can end up with a few mistakes here and there, or a few percentage differences over time. So archive that calculator, archive the documentation of the sizing process, hang on to it. It's also useful if there's any sort of support question in the future from a sizing perspective. It's very useful for my team and Microsoft support more generally to be able to look at that information and see how the system was designed, how it was intended to perform. Very useful information. So let's go ahead and talk about the nitty-gritty, the interesting stuff. Changes in Exchange 2013 and how they impact sizing and performance. So I'm not going to spend a huge amount of time on this slide. I'm guessing many of you have seen a slide that looks like this by now in terms of the diagram, going over the overall architecture. But from a sizing perspective, Exchange 2013 targets what we call balanced use of hardware. What does that mean? I'm going to talk about balanced use of hardware in a few different ways over the next few minutes. But in general, what we're talking about here is rather than having a set of roles in the product that use hardware in different ways and don't necessarily use all of the hardware on a server in the best way possible. Instead, we have a smaller number of roles that ideally use all of the hardware that's available to that role in a balanced way. So instead of being very CPU heavy or being memory heavy or being disk heavy, we want to be able to use memory, CPU, and disk at a fairly even rate, right? Means that we can ideally buy cheaper servers that oftentimes we call commodity class servers, and I'll talk about that in a few minutes as well. But it also means that, that in general, from a scalability perspective, we end up in what we call kind of a brick platform. So think of building a wall with bricks. Very simple unit of scale. Rather than having a unit of scale that is some number of mailbox servers that uses hardware in some way and some number of CAS servers that is balanced to that set of mailbox servers and some number of hub servers that's also balanced to that number of mailbox servers. Instead, we just have a set of mailbox servers, perhaps with the new CAS role co-located. So the roles are loosely coupled. They're scaled independently, which means that CAS scales completely independently of mailbox. As you need more connections, you can scale CAS up. And because of this reduction in roles, we really only have 3 that we think about for sizing, and maybe only 2, actually, if you co-locate CAS and mailbox. You still need to think about Active Directory. It's not going anywhere. We're still very reliant on AD. So, talking about the mailbox role. And actually, well, before we get to the mailbox role, more generically, some minimum requirements. So memory requirements have absolutely increased. Anybody out there, when we released the Exchange 2013 beta, try and install on a virtual machine with a small amount of RAM and discover that it didn't work so well? Yeah. We discovered that very early on in our own labs because we run a lot of virtual machines for testing. And it's very painful with Exchange 2013 to deploy on a VM that has, say, 2 gigs of RAM, which you could do pretty easily with Exchange 2010. With Exchange 2013, we require 8 gigs of minimum RAM for the mailbox role or a multi-role server, mailbox plus CAS. Or if it's CAS only, we require a minimum of 4 gigs. This is for production deployment. You can tweak this a little bit. You can get away with a little bit less in test if you're building out a test lab. But for production, these are the requirements. Keep in mind, that's bare minimum, right? If you're actually sizing for performance, if you want your users to have the best possible experience, these are not the numbers for you. You actually want to go through the process of figuring out what the right memory sizing is. In terms of disk space, we've also dramatically increased the minimum. So we actually require a minimum of 30 gigs of free space on the drive where you're installing Exchange. And the reason for that is some additional diagnostic logging that's enabled by default. That's there for a number of reasons. I alluded to some of them when I was talking through the Exchange Diagnostic Service, which is responsible for probably about 7 or 8 gigs of that 30. There's a number of other logging sources that are enabled out of the box that are very useful for you to understand how your system's being used and useful to Microsoft for troubleshooting if you run into problems in the future. Hopefully 30 gigs is not a big deal, given that disk space is a little bit cheaper today than it was in 2010 and certainly a lot cheaper than it was in 2007, but important to be aware of that increase. So, talking specifically about the mailbox role for the next few minutes. So I mentioned the simplified deployment model. Reducing the old mailbox hub and CAS into a single role obviously simplifies deployment. You don't need to think about how many of each of those things you need. You just have the one thing to size for. Because of the change in architecture in 2013 and the fact that the mailbox role is responsible for handling all transactions for users, a particular mailbox server is responsible for handling all transactions for users whose active copies are running on that server. That means that we actually get much better use of cache memory on those servers, right? Instead of having requests for a given user, we'll say me, being spread out across a bunch of different CAS servers due to load balancing, potentially a bunch of hub servers as I'm sending and receiving mail. And, well, mailbox server isn't a great example, but from a CAS and hub perspective, Exchange utilization of caches was actually not great in 2010 because of the sort of distributed nature of the system. In 2013, because all the activity for me is being handled on one particular mailbox server at any point in time, the caching of information for my account, for my data on disk, is actually much better. It's a much more effective use of cache. So that's a performance improvement that we definitely see in production. I mentioned balanced resource utilization. We'll talk about that some more as the talk goes on. In terms of considerations, there are increased requirements from a hardware perspective for the mailbox role in 2013. We are definitely using more CPU, and we are definitely using more memory. No question about it. And if you've used the calculator, that should be fairly obvious. I will say that the increases are not quite as dramatic as what some people have claimed or asked questions about. I've gotten questions along the lines of, why has CPU increased 4x? CPU utilization increased 4x in Exchange 2013 compared to 2010. It's not 4x. Because of the architecture change, it's a little difficult to compare apples to apples, so I can't stand up here and give you a specific number. I can tell you that, in general, the calculations that I've done around this show that it's less than 2x. But it's really going to depend on your specific situation to look at what the difference is. And really, at the end of the day, the only way to truly know what it is to go through the sizing process with a 2010 deployment as you might use it today, and a 2013 deployment with the same configuration parameters on the same hardware, and then look at the difference, right? And the answer for that will likely be different for every single person in the room.
So I have a couple of questions, because I've actually done exactly what you said, and I'm seeing CPU utilizations at 4x and RAM requirements at 6x.
Okay.
So my question actually isn't about this, because I know it's a reality on the calculator. It's more related to when you were saying you gather real-world performance data. What percentage of that comes from a Microsoft deployment as opposed to customers? Because a Microsoft deployment skews the sizing so terribly, it doesn't really reflect what my customers are actually doing.
Yep. So I'm going to answer that, but then I'm going to ask everyone to hold your questions until the end. I've got a lot of content, got to make sure I get through all of it. So I will cover that briefly, though. So, and I also have to cover the calculator difference piece towards the end. You cannot compare the output of the calculators directly. And I'll explain why. In terms of where the guidance comes from, so 100% of the guidance for Exchange 2013 comes from a Microsoft deployment, 100%. Having said that, not everyone at Microsoft is the same. We actually have quite a variation in terms of usage at Microsoft. So if I went and just looked at the portion of dog food that is the Exchange team, we don't have a profile that defines what the Exchange team is. We use email in ways that email was never intended to be used, quite frankly. And you're in the email team, you don't pick up the phone, you don't get up from your desk and go talk to the person next door, or maybe across from you if you're in a cubicle. You send them mail. So we're in the multiple thousand profiles typically for people in the Exchange team. But we have people at Microsoft who have the 50 profile and have the 100 profile. So we actually are able to look at what those profiles look like. Our guidance is conservative. There's no question about that. And we do that to allow for, basically to make sure that you're not going to get into a state where things are undersized. We want you to be oversized, if anything, because you'll end up with a better result than the alternative, obviously. So there are trade-offs for this increased resource utilization. You are getting some benefit from it. Managed availability is a great example. That's a trade-off in, ideally, in OpEx for some additional CapEx, right? We're doing some work behind the scenes to constantly monitor your system, constantly go in and understand whether or not various protocols are reachable, whether or not databases are usable. And as a result of that, obviously there's going to be some performance impact. Every time we go do a login, that's going to cost something from a performance perspective. Doing that across all of our protocols, all the databases, all the servers, all the time, there's impact. Reducing I/O. We reduced I/O again in 2013. We pay for that with memory, and we pay for that with CPU. Moving to a managed store process and the store worker process model. That means that instead of one store process, we now have a store process for every database on the mailbox server. There's an increased cost, particularly around memory for that. And since it's a managed process, there's also a CPU cost as well for managing that managed memory that .NET provides. So there are trade-offs. I can't enumerate every single one of them, given the time that I have. But it's just important to be aware that, yes, there are increases. Yes, you are getting something in the architecture for those increases. And I'm going to cover everything else on this slide in a future slide, so I'll go ahead and move on. So when we think about storage capacity requirements, we're basically looking at the same things that we looked at in 2010, right? You're sizing for the mailbox size of your users on disk. You're sizing for content indexes, and you're sizing for log space. Same idea. There are some important changes to how we size here. One of the biggest, in 2010, we asked you to add an additional 20% overhead for what we called just general database overhead. That was sort of the extra space that was the difference between what mailbox statistics said in terms of what users were actually using and what we actually saw in terms of utilization on disk that we couldn't really explain easily, so we just called it database overhead and told you to add 20%, and that would cover it. The recommendation for 2013 is that should be 0. So there's a nice benefit. It's 20% of space utilization that we just removed from the product. There's a number of reasons for that. We're actually doing a much better job compressing data on disk than we have historically, compressing data in JET. That's probably the biggest reason for this reduction. So now that I've made things better, I'm going to make things worse again. So CI has an increased space utilization in 2013. It's up to 20% of the database size now, with an additional very important caveat that should probably be a full bullet point on this slide. We actually require an additional space for an additional set of indexes on every volume where you have Exchange databases located. And that's used for the content indexing master merge process that goes through and sort of performs maintenance on the content index database, just to kind of cover it with the Cliffs Notes version. You can mitigate that a bit via multiple databases per volume. So what I'm essentially saying here is that on a given volume, if you have one database, you need 20% of the database size for CI, and you need an additional 20% so that master merge can go and create an optimized copy of that database on a regular basis. If you have 4 databases on disk, you'll need that 20% space for each one of those databases, but you only need 1 additional log set for master merge. You don't need 4 more. So this is actually a great reason to consider using multiple databases per volume. One of the many good reasons to do it. So worth considering. So Scott Schnoll announced earlier today that in CU2, we're increasing the maximum number of databases per server back up to what it was in 2010. We're moving it from 50 back up to 100. Scott tells me he got no applause in his session about this, which surprised all of us who did a whole bunch of work to go make this happen. So out of curiosity, is anyone actually excited about this? Is this a good thing? OK, a few people. All right, good. I told Scott that if I didn't get any applause, I'd tell you that I was taking it away in CU3. So we'll leave it at 100. Yeah, so at RTM, we were not 100% convinced that the product was ready to have 100 databases per server. Because of the architectural change of having a store worker process per database, because of managed availability, doing a whole bunch of work on a per database level, we needed to be very sure that Exchange, frankly, wasn't going to fall over with 100 databases per server. And we needed to get really good production coverage before we made that an option. We feel comfortable with it in CU2. So we are aware that was kind of a sizing limit for some customers that was resulting in workarounds in terms of the sizing process. In some cases, inflating the number of servers you might need. In other cases, causing some customers to decrease the mailbox sizes of some users to get around this. So very happy that that's back up to 100. In terms of IOPS, once again, in 2013, we have reduced the I/O profile for our users. We advertised broadly, loudly, when the product was released, that reduction was another 50%. If you go look at the sizing guidance for 2010 and 2013, you'll see that it's more like 33%, not quite 50. So we didn't lie. I mentioned earlier that sometimes we come out with numbers that are based on lab tests, and then we revise those based on production observations. This is one of those cases. So in lab tests, in very specific scenarios, we see about a 50% reduction in I/O if you compare similar user profiles on Exchange 2010 and Exchange 2013. When we go look at production and look, with all the variability that comes with a production workload, we see something more like 33%. And because we want you to be as successful as possible when going into production, we use those numbers from our production observations. So, we're definitely continuing on a downward trend from an I/O perspective. We have also made a change to sizing guidance around standalone servers. In 2010, the I/O requirements for standalone databases, where you weren't using a DAG, you didn't have multiple copies, the I/O requirements for those was higher because the checkpoint depth for those databases was lower. Checkpoint depth is now consistent across all database copies, regardless of whether you have no copies or 16 copies. Or I guess I should say 1 copy or 16 copies. So because of that, we've simplified sizing guidance. The IOPS numbers are the same regardless. From a storage bandwidth perspective, and this really matters if you're using some sort of storage networking technology, could be iSCSI, could be Fibre Channel, any storage technology where you could potentially bottleneck on the network connectivity between a server and the storage subsystem. We've made a change in 2013 that impacts this. So background database maintenance can actually have a fairly major impact on bandwidth utilization on a storage network, because we're effectively constantly going and reading database content for all the databases on the system as part of this maintenance process. We're actually throttling it down a bit more in 2013 to the point of only consuming 1 meg per second per database copy. It's a fairly dramatic increase from 2010. So less of an issue in 2013. Still could be an issue, though. It's important to be aware of this when sizing in those types of environments. So transport. I'm actually really happy we're talking about transport here. We haven't had good transport guidance in a really long time. I think the last time I remember talking about transport guidance was 2007, and we said something like every message sent through a hub server in 2007 was 17 IOPS or some number like that, which is just ridiculous. For 2010, we didn't have good numbers here. So very happy to be able to point to some numbers for 2013, and they will get more detailed over time. We do have some ongoing data collection in this area to improve this guidance. So in the role requirements calculator and in the blog post that describes our sizing guidance, we talk through how to think about capacity requirements for transport in terms of the queue database, as well as safety net, which is the evolution of the transport dumpster. And we actually describe very specifically, using average message size and some other inputs, how to calculate how big your queue database needs to be, or could be. From an I/O perspective, very high-level guidance to start out with here. We're saying that you'll see about 1 I/O per message at an average message size of 75K. You can expect that will go up as the average message size goes up, but much lower than the 17 I mentioned from Exchange 2007 in this release. We do think that it's absolutely realistic to deploy your transport queue on your system drive. In production at Microsoft, we're actually deploying our RAID 1 pair using cheap big disks, slow SATA or midline SAS drives in a RAID 1 pair for the OS, the Exchange install, including the transport queue. We don't move the transport queue. And we're finding that that has more than enough IOPS to service transport for our needs. So dramatically simplifies the process of configuring hardware, dramatically simplifies the sizing process when you think about where transport's going to go. We do recommend a protected write cache disk controller. Historically, that would have been a battery-backed write cache. Now, there's other technologies other than batteries, thankfully, that can provide that same benefit. What that means is that you basically end up with free log I/O. All those log writes that are happening as messages are coming through the transport, from an I/O perspective, are basically free. So it allows throughput to increase fairly dramatically. So let's talk about CPU for a few minutes. This is one of the areas where we've seen requirements go up fairly dramatically. So from a sizing perspective, we size CPU based on megacycles. A megacycle is a unit of work, and via the sizing process, you will calculate how many available megacycles your hardware has. I'm not going to go through that here because it's much easier to do using some of the tools that we'll talk about in a minute. But once you figure out your available megacycles, you can then go look at what the megacycle requirements are for particular user profiles, and calculate how much CPU you're going to consume of that available CPU on the box. So if you were to go compare this chart to the one that was published for 2010, you'd probably say, wow, they're pretty similar. Looking at the second column, the megacycles per user for active database copy or standalone, mailbox only, that would have been something like 2, 4, 6, 8, 10, 12, et cetera, for 2010. So not a dramatic increase. The challenge is that nice bright orange box down at the bottom. The megacycle guidance is based on a particular hardware platform. And the way you calculate available megacycles is specific to your particular hardware platform that you want to deploy on. And there's some math that goes into normalizing this so you get the right results for specific hardware. Because we had a different baseline platform for 2010 and 2013, you can't compare these. There is a fairly dramatic increase behind these numbers for 2013. We are, however, doing something nice, and that is showing you the numbers for multi-role to try and make it easier to size for multi-role, because we think multi-role is a best practice. We think it's actually probably the best way to deploy 2013, unless you have a good reason not to, which I'll talk through in a few minutes. We did remove the per passive multiplier. So in 2010, in order to figure out megacycle requirements for an active server, we had a chart like this, and then we said, in addition to whatever number is in that second column, add, I believe it's either 10 or 20%, I don't remember which, for every passive copy associated with that active copy. That actually resulted in some really big numbers for complex DAGs. We don't do that anymore. The costs for passive copies are actually included here in those numbers. Hyperthreading. This is an area that I've gotten a lot of questions on over the years, and we actually have a very specific set of guidance on hyperthreading for 2013, and that is, don't do it. There's a reason for it. Unlike some of the, less than specific reasons we might have given you in the past. Yes, you will get some benefit from turning hyperthreading on from a CPU throughput perspective. No question about that. Modern symmetric multithreading, hyperthreading, absolutely gives you a benefit in throughput. Really can't argue that. Anywhere from about 15% to maybe 25% benefit in throughput from our lab tests. But all of the processes that run in Exchange are managed code. Managed code handles memory in a very different way. And one of the ways in which it handles memory in a different way is based on allocation of heaps. A heap is kind of a unit of memory that's used by the memory manager for, we don't need to get into details too much on heaps, but think of a heap as a set of memory on the box that's allocated at startup to make it very efficient to allocate memory for that process over time. So when .NET processes start up, there's two different types of .NET processes. There's workstation processes and server processes. Workstation processes are designed for workstation use, applications on a laptop. Server processes are designed for high-throughput server applications. In order to basically provide high-efficiency allocation of memory, the server garbage collector in the .NET framework allocates heaps per logical CPU on the box. So if I have a box with 16 physical CPU cores, it's going to go look at that and say, OK, I have 16 CPUs. I'm going to allocate 16 sets of heaps. And that way, each one of those processors can be doing allocation work simultaneously. That's what's happening behind the scenes. Because it looks at logical CPUs, that means if I turn hyperthreading on, it's now going to allocate 32 sets of heaps. That means that if I compare the amount of memory utilization at start, before these processes have done anything, no workload, no nothing, I'm going to effectively double-ish my memory utilization by having hyperthreading turned on. So the reason we're recommending not turning hyperthreading on is because we don't think the increase in memory utilization is actually outweighed by the improved CPU throughput, that 15 to 25% CPU throughput. That's the reason for it. So our recommendation, very strongly, is to turn hyperthreading off. So this slide is actually brand new as of yesterday. I put this in here on the plane on the way down. So we've discovered in our own internal deployments that there is a new hotfix available from the .NET team that actually has a dramatic impact on Exchange. And it will reduce memory utilization by about 200 megabytes per store worker process. So for those of you who plan to deploy 100 databases per server, now that you can in CU2, that's a lot of memory. Unfortunately, this is not yet what we call a GDR, a general distribution release, which means you can't just go to the web and download it. You actually have to call Microsoft support to get access to it. We are going to try and turn this into a GDR over time. But we do recommend this as a best practice, that you go get this, obtain access to this hotfix and deploy it. You'll have a lot more memory available on your system for peaks in demand. So definitely a best practice. So in terms of memory requirements, the way we sized memory in 2010 was a little more complex than what we're doing in 2013. You had to go figure out your cache requirement per user. Depending on whether or not you were doing multi-role or not, with multi-role, we didn't have fantastic guidance other than think about half of the server for mailbox and half of the server for everything else. There was some more complexity around memory sizing. For 2013, we just have one number. That's the set of numbers you see here. They're actually still based on database cache. So in 2013, when store starts up, it looks at the amount of memory on the system and takes 25% of that and allocates it to database cache. Our database cache requirements have stayed the same between 2010 and 2013, which means that these numbers are exactly 4x the cache requirements for 2010. We want to make sure that we're allocating the same amount of cache memory. So in order to do that, given that 25% of the memory on the box is for cache, we just multiplied those numbers times 4, and that's what you see here. We have gone, we didn't just stop there. We did go through and make sure that this amount of memory on a per user basis would give us enough memory to handle all the other stuff running on the box. CI actually has a fairly significant increase in memory utilization in 2013, much more noticeable than 2010. There are benefits to that. The CI platform in 2013, way better, way faster from a query perspective. Does a much better job keeping up with indexing. And frankly, it's much more supportable. It's modern technology that we're much more comfortable with, that's being used across multiple products in the Office division. So that has a fairly significant increase. With the store worker process model, we also have an increase in memory from that. In general, the CAS and hub components are very similar in terms of memory utilization to what we saw in 2010. And those are accounted for in these numbers. There is no addition on top of this. There is an addition for the CAS 2013 set of components that are sort of a net new addition in this release. We'll talk through that in just a second, like now. So if we have a multi-role server, we do need to think about memory for those CAS components. And I'm going to mention CPU sizing for CAS in a few minutes. Basically, the ratio for CAS sizing from a CPU perspective has changed from 3 to 4, as it was in 2010, to 1 to 4 in 2013. So 25% of mailbox CPU needs to be allocated for CAS 2013. The guidance for memory for CAS is 2 gigs plus 2 gigs per core serving active user load. This formula basically gives you that number. So what it's doing essentially is going through and figuring out how many CPU cores are being used for active user load, taking 25% of that, effectively, multiplying it by 2, and then adding 2. That's what it's doing. If you use the calculator, you don't have to do any of this. So use the calculator. There are also some scenarios where you might have a very small number of highly active users on a database. You can run into cases where the sizing guidance actually may give you a very low number from a memory sizing perspective. So there are some minimums in place to make sure that in those cases, we have enough memory to actually do some work. And that's where these minimum memory requirements come into play. Very rare scenarios. I don't see these too often, but maybe we have some notes customers out there who want to have a single mailbox per database because they like that model. That might make sense for a particular scenario. So be aware of the minimum requirements. From a network perspective, we like network sizing to be as simple as possible. Ideally, you shouldn't have to care about it. We are seeing a lot of customers go to 10 gig Ethernet in their data centers. Out of curiosity, how many of you are deploying servers with 10 gig Ethernet today? All right, that's a lot more than I saw a year ago. We've started moving to this in our own data centers, and in many cases, we're deploying a single 10 gig Ethernet interface on our Exchange systems, with the idea that we don't want to have to deploy 2. That adds complexity, it adds cost. We're already designing for failures. We're already assuming that hardware is going to fail or software is going to fail, and so those servers can go down, and we'll just use the high availability functionality that's built into the product to recover from it. So we don't need multiple interfaces. 10 gigs meets our needs for seeding, meets our needs for access to data. So it simplifies things pretty dramatically. And that seems like a best practice. Keep it simple, right? So wherever possible, avoid bottlenecking on the network. 10 gig Ethernet helps with that. You can do it via other methods. If you have a fairly small Exchange solution, you may not need more than gig Ethernet, 1 gig Ethernet. So just avoid bottlenecks here. That's really the key. Unified messaging, bit of a challenge. So as in 2010, unified messaging is sized based on a concurrency model. That means that we provide guidance around the maximum number of calls that unified messaging can handle simultaneously. Great. In 2010, you could have dedicated unified messaging servers, and you could scale up the number of servers based on your concurrency requirements. Very easy. The challenge in 2013 is that is part of the mailbox role. Anybody catching a little problem here? So you can't have a dedicated server anymore. And just like everything else in 2013, is going to use the mailbox server that is currently hosting the active copy of the target user's database. So this means that you need to think about how users are spread out in an organization if you're going to be a heavy user of unified messaging. You need to make sure that you're not going to run into this 100 concurrent calls per server limit by having clusters of users who are heavy consumers of unified messaging on a subset of servers. You need to make sure that they're spread out as much as possible. That's the challenge with unified messaging. It's also important to be aware that voicemail transcription is a very heavy user of CPU, very heavy. uses about a CPU core for the duration of the transcription process per message being transcribed. And it will actually go and look and see if it has that CPU available to it when it runs. If it doesn't, it just won't do the transcription. It'll just email the voicemail message without the transcription. So it won't overwhelm the server and impact everything else that's happening on that server in order to get the transcription through. But if it's very important to you and your users that those transcriptions always happen, you may have to increase the amount of CPU on your servers to make sure that you always have those resources available. For the other CPU requirements for it's basically the base CPU that's needed to handle receiving and managing calls. That is actually included in the sizing guidance for the mailbox role. We don't separate that out. So really what you need to think about from is concurrency and spreading out users and making sure that if you do plan to do significant amounts of transcription, that you have those available CPU resources on top of our existing sizing guidance for mailbox. So the new CAS role. CAS is very simple compared to what it used to be. It's a nice stateless role. All it's really doing is proxying connections, right? It's going and figuring out what mailbox server is associated with the request and proxying the connection to that mailbox server. Very simple. Scales up and down very easily. If you need more connections, you add more CAS servers. We do consider this to kind of be a net new role in 2013. So when I think about comparing the performance of 2010 to 2013, I think about what CAS 2013 is doing as sort of the intelligent director of traffic work that you might have associated with a load balancer in 2010. I think of it as something that wasn't really there in 2010, so it's hard to compare. A little bit of a different mindset, I know, than what a lot of people have been thinking in terms of making that comparison, but that's how we think of it internally. So in terms of CAS CPU requirements, I mentioned already that we went from the 3 to 4 ratio that we had in 2010 down to a 1 to 4 ratio, or a 25% number in 2013. So we have found in some cases that you actually end up with a very small number of CAS servers as a result of this calculation. In some cases, 1. You don't want 1 CAS server. It's bad for high availability. When that CAS server dies, and it will, everything dies. All hardware fails at some point. All software fails at some point. Everything has bugs. You want to make sure that you actually have more CAS servers to pick up that load. So you'll find that in the role requirements calculator, Russ does something very intelligent. He goes and figures out the number of CAS servers you need, and then he adds 2. Because we always size for 2 failures in the role requirements calculator. So by just adding 2, we know that we can lose 2 of those servers and still meet peak demand. You should consider taking that advice. CAS servers are, because they're stateless servers, they don't really need disk. The other way to deal with deploying more CAS servers is to use multi-role, right? Then every mailbox is a CAS server as well. So this formula will look very similar to the one I showed earlier. This is if I'm just deploying CAS and not doing multi-role, how do I compute my memory? 2 gigs plus 2 gigs per core. So this is going and figuring out how many CAS server cores are going to be used at peak, multiplying that by 2, and adding 2. There is no reduction in our CAS memory guidance in 2013. We had the same 2 gigs plus 2 gigs per core in 2010. But there are less CAS servers in 2013 as a result of the CPU ratio change. So the overall amount of memory that you're deploying for CAS in 2013 is going to be fairly dramatically reduced. So why wouldn't you multi-role? It's really only 2 reasons that we've been able to come up with. My friend Greg Taylor and I were having a great debate about this back in February at an internal technical conference, trying to figure out what our guidance should be here, because we were getting asked over and over again what we should tell customers. And the way we were looking at it from the perspective of why you would want a multi-role. We kept coming up with more and more ideas and decided finally, well, let's look at why not. That's a much easier question to answer. And there were only two things that we could come up with. If anyone in the room has other reasons, love to hear them. Come to Ask the Experts tonight and tell me. But the only two that we were able to come up with were Windows NLB. If you want to use NLB for load balancing, there's a compatibility issue. You cannot use Windows NLB in this configuration. We generally advocate not using Windows NLB anyway, so I don't think it's that big of a deal. The other one is certificate management. So depending on where you get your SSL certificates from, there may be a per server charge for those certificates. I've never worked with an SSL certificate provider that did this, but I'm aware that there are some out there who do. And if that is the case, if you went to multi-role, then you'd basically be deploying that cert on every mailbox server. You'd have you need a lot more instances of that certificate than you would otherwise. If you're not in that case, then you can ignore that as well. And multi-role really becomes a best practice, something that everyone should consider doing. So in terms of AD requirements, there's no change here. This is the exact same thing we recommended for 2010. 1 AD global catalog core for every 8 mailbox CPU cores handling active load. Easy to calculate this in the role requirements calculator. It'll tell you how many CPU cores you need for global catalogs, either single site or multi-site if you're going to do a site resilient deployment. We do recommend sizing memory such that the entire database file that AD uses can fit in RAM. So that ntds.dit file, you want to make sure you can load that whole thing into RAM. Dramatic increase in query performance, much better end user experience. So using the calculator, I'm going to do a quick demo here before we close up with details on the remaining tools. So a little bit of background. We've actually had many calculator projects over the years. I can think of probably 5 off the top of my head. This is the only one that's ever really been successful. Some of them actually, well, one of them ended up as a shipped product, the System Center Capacity Planner tool. I don't know if any of you ever downloaded that and tried to use it. What we found over the years is that the more complex you try and make a calculator, the more complex the model of the system is that you try to build, the worse the results. We think that the role requirements calculator is actually a great balance between being specific enough to give people the information that they need and being vague enough that we don't get into trying to provide guidance on things that we don't fully understand. The failures in the past have been around things that tried to figure out like what the individual unit CPU cost was of sending a mail in OA versus opening the calendar. Those are very hard measurements to make, and when you multiply those measurements by the tens, hundreds of thousands of times, maybe millions of times that those actions occur in a day, you end up with wild divergence in predictions. So we really like the role requirements calculator. We've gotten a lot of great feedback on it, and we think that it's doing the right thing. We also love feedback. So if you find that it's not doing the right thing in a particular scenario, we want to know that. It lets you try out various scenarios, right? You can go in and fairly easily go and modify the inputs and understand what the impact is from a sizing perspective on your deployment. So it's a cheap, painless way to go model different options. It also, in recent releases, does some automation around setup and configuration. So it'll actually spit out PowerShell scripts that will create DAGs, create databases, create database copies. So nice benefit there. You can go from the sizing process to actually deployment within one tool. In 2013, we are now doing CAS sizing as well as transport sizing in the calculator as well. That's why we removed the mailbox word from the title. So let's go ahead and quickly walk through a scenario. All right, so the calculator is an Excel spreadsheet, which is awesome for a number of reasons. There's no additional install. It also works really well with a touch screen. It means I can zoom. So I'm going to quickly walk through a scenario. Let's say we have a small business. We'll call it Greg's Grass. Greg Taylor, one of my coworkers, has a lawn care business called Greg's Grass. It's a wholly owned subsidiary of Contoso Corporation. And it has 10,000 users. It's a fairly large lawn care company. So we'll come in here and give Greg's Grass 10,000 users. Those 10,000 users have the 100 profile. So we'll just select that from the dropdown. And the average message size is 75K. All of these folks that go out and deal with people's lawns, all 10,000 of them, this army of lawn maintenance technicians, we're going to give them all 1 gig mailboxes because it's Exchange. We love big mailboxes these days. So I like that Ross has the default as 10 gigs. That's awesome. We would love it if everyone had a 10 gig mailbox. How many of you in the room have a mailbox that's bigger than 1 gig for Exchange? Awesome. That's fantastic. Bigger than 2 gigs? 3, 4, 5, 6. Okay. Bigger than 10 gigs? Unlimited? I like my unlimited mailbox. Okay, so we'll make this 1 gig. And we're going to use DAS storage, so JBOD, cheap disks. So we're going to go with 4 terabyte drives that are available in market today, and try and get the most advantage out of that storage that we possibly can. So down here in the server disk configuration, we'll leave the disk capacity set to 4 terabytes, and these are midline SAS drives, basically SATA drives with some additional electronics on board to make them a little more reliable. So we're going to go with a single site. I'm not going to use site resilience. So we'll go over here to the site resilience configuration, and we'll change this to no. I don't need a secondary data center for Greg's Grass. And we're going to go with multi-role, which is the default, given that we're considering that a best practice. We're not going to use virtualization. We are going to use high availability. We're going to use a DAG. I definitely don't need 8 DAGs for 10,000 users. We'll go with 1 DAG. And I'm just going to start with 4 servers just to see how we do with that. I'm not going to do any backup other than what's built into Exchange with Exchange native data protection. So we'll leave that as is. And for my server hardware, I need to tell the calculator what my CPU resources are. So I'll talk through in a second where you can get this number. We have a great tool that'll give it to you for a particular server platform. But the benchmark value for the server platform I'm going to use is 540. So I put that in. So that's really all I need to do for a very basic sizing exercise for 10,000 users with the parameters I configured. Yep. 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 All right. So given what I've put in, let's see what the calculator tells me. So if I scroll down here, you'll notice that there's a cell that's highlighted, as well as a message here that says, 1 or more disk types you've selected for this design is insufficient for deploying a JBOD solution. And the highlighted cell is around disk type. What that's basically telling me is that that type of disk isn't providing the right IOPS for what I need for this user configuration. If I go over to the Role Requirements tab down at the bottom, wow, that's small. Let's zoom in a bit. I can go and get a little more detail about what the specific requirements are. And if I scroll down through here, I'll see some more highlighting. So this is actually telling me that my server CPU utilization in a worst-case failure mode is 104%. That's obviously not good. That means I can't meet the demands of my workload if I get into that worst-case scenario. So I know that I don't have enough IOPS, and I don't have enough CPU, so let's add a couple servers. This is easy, right? Don't actually have to deploy them. It's just a calculator. You can just go change the number. So let's change this to 6 servers. So if I scroll down again, hopefully this isn't making you dizzy. If I scroll down again, I can see that highlighting's gone from the disk configuration. So I know that in the back of the calculator, I'm now OK from an IOPS perspective. If I go back to the role requirements side, I can see that my server CPU utilization is now 63% in a worst-case failure mode. We recommend never going over 80% in worst-case failure, so I'm happy here. And I've got a little breathing room as well. I could potentially get a lower spec CPU If I wanted to, I could maybe change the user profile if I want to be able to handle increase in user mail flow and understand what that would actually look like. If I go through here, I also have a distribution tab. This is one of the nicer tabs that shows up. What this is actually showing me is that within the DAG, what will happen if one of those 6 servers fails. So each one of these is these rows here is a database with servers in the columns. So what this is showing is database 1 here has its active copy number 1 on this server, copy number 2 here, 3, 4, et cetera. So if I fail the first server, what this will show is actually how copy activation changes and how those active copies get moved around in order to keep users up and running. So I can model failures very easily here. If I have a site resilient deployment with multiple DAGs, I can actually understand the impact of failing WAN connections as well and see what would happen in those scenarios. This is also where I can go and do things like export DAG configuration and export scripts that will automate the creation of all of these databases and servers and DAGs. Very cool. The volume requirements tab, this actually shows me for each one of the database volumes how much space I'm going to need. I'm deploying 4 terabyte drives, and it looks like I'm only going to be using about 1 terabyte on each of those drives. So I could now go back and change my mailbox sizes and go and understand what the calculator would actually predict based on those changes. I now can tell you right off the bat that all those employees at Greg's Grass can absolutely have 2 gig mailboxes, no problem. Probably dramatically higher with no other impact to the system. So very simple to go in here and input a design, understand what the implications are as you go and make changes to that design and make some predictions. So I'm not going to go through the entire calculator, just wanted to give you a sense of what's available in here. So real quick, just to close things out, go through the remaining tools and resources that are available for you in the sizing process. So the official sizing guidance for 2013 is available on the Exchange team blog currently at that gigantic address down at the bottom. It will be available on TechNet in a future milestone release on the TechNet website for Exchange. But at the moment, this is the official guidance. We'll keep it up to date in this location as things change. We do have a query tool, like I mentioned, that lets you get that benchmark result that goes into the calculator for a particular hardware platform. Very easy to go put in a particular processor model and get the right number to use in the calculator for that processor type. Highly recommend using jet stress on every Exchange deployment to make sure that the storage subsystem sitting behind Exchange can actually meet the I/O requirements of Exchange as you plan to deploy it. Jet stress is a really quick and easy tool to use to validate this. You can also use it to break in hardware, right? Make sure that you don't have a batch of bad disks, because that happens, unfortunately. It's really good to run in sort of a pre-production mode just to make sure that your hardware is ready to go before you actually move it into production. Along with jet stress, we actually have a program called the Exchange Solution Reviewed program that a number of our hardware partners participate in. And this is a sort of a solution guidance program where our hardware partners are basically providing the Exchange storage solutions that they would recommend to our joint customers and proving using jet stress that those storage solutions can meet a particular set of user requirements. And they document what the user requirements are, what the tests were that were run using jet stress, and you can use those as starting points to build an Exchange solution. Load gen is absolutely coming for 2013. We have decided to build a version of load gen for 2013. It's not yet available. It is going to be coming soon. All I'm going to say here is this calendar year, but it's going to be sooner than December, I can tell you that. So we're including in the new load gen tool support for the changes in connectivity model for 2013. So Outlook Anywhere for everyone. Obviously, or RPC over HTTP, obviously a major change. There's a number of stability fixes and many bug fixes in the tool. So hopefully easier to use, more reliable if you need to use load gen to actually validate user workload in a test lab. So we'll be announcing the availability of this on the Exchange Team blog, hopefully in the very near future. So with that, there's a number of related sessions, some of which have already happened, others of which are later in the week. If you have specific questions on virtualization sizing, I'll be talking about that this afternoon in the last session on the breakout list here. If you do have other questions, definitely come find me or Ross, who's standing up in the back, to ask the expert session. And with that, I will say thank you.